All right, next video. This is chapter 3 continued. Functions and their graphs. Chapter 3. This is section 3.2, the graph of a function. Now this could be a very big topic all in itself, but they're talking about graphs of the functions that you've seen before, most likely here. So identify the graph of a function, obtain information about the graph of a function. And so both are important. It's not just drawing the function, but asking graphing questions. So questions about the graph. So in the previous, one of the previous videos, we talked about a function. Vertical line test will tell you if a graph is a function. So there's a big important relationship here. So the idea of a vertical line test is every vertical line, if I just kind of sweep this vertical line here, it will intersect the graph at most one time. And that's what I want. That's what I need to see if I'm talking about a function. So both of these pictures are functions. Both of these fail the vertical line test. Here's a vertical line that intersects the graph twice. Has to be a vertical line. Right? Vertical line that intersects twice. Another vertical line that intersects twice. So these are not functions. They are graphs we're going to need to know at some point, but not in a section of the book called functions. It looks like the same thing. Oh, okay. It's the vertical line test. So they just explain the two graphs. They really over explain that. You don't really need to know the numbers. You just need to know that visually it intersects it more than once. All right, so this example is they give you a function. They don't really tell you what this function is. It's a function of trigonometry, as it turns out, but we don't need to know that. So here's a function, and they ask you questions about the function. So what's the domain? What's the range? What are the intercepts? Is it a function? Does it pass the vertical line test? I'll go ahead and tell you, yes, it does. It's a function. So you can see all the questions they're asking us, and the questions are not necessarily just about the graph. I don't think a student has ever come through an algebra class thinking, all I need to know is how to graph. No, they might ask you questions about the graph. All right, so we'll get to those. All right, so part A, they must have been asking, what were they asking in part A? Sorry. Find f of 0, f of pi over 4, f of pi, 7 pi over 4. All right. Should be kind of obvious what they're asking. So they're just asking for numerical questions here. So f of 0, we don't have the function. All we have is a picture. So you have to look at this, and I like to think of it this way, is what if I had a table, and this was point A, the table would be 0, 0. So what that means is, should have been A. What that means is when I put in 0 for the argument, I get 0 for the second value, or 0 for the result. And they're saying what happens at pi over 4? Here it is. At pi over 4, the result is 2. Right? And so to write that as, in function notation, f of pi over 4 equals 2. Make sure you keep the order properly, lined up here. And then this next one, f of 7 pi over 4. So you got to find that, 7 pi over 4. And what it says is f of 7 pi over 4 is negative 2. And so let's put it in my table, negative 2. And so what I have here, that's the argument, and what I have here, that's the result. Part B is asking us, what's the domain? And basically, you just want to ignore the height of the graph, and you just want to know what's the leftmost and rightmost point, or the x value of the leftmost and rightmost point. So that's it. The x value of the leftmost point is 0, and the x value of the rightmost point is 2 pi. So the interval is from 0 to 2 pi. So it's the minimum, comma, the maximum when you write it in the interval notation. Now the range I have to look down here. What's the minimum y value? So I'm ignoring the x's. The minimum y value is -2 right here. Didn't mean to cross that out. I just wanted to kind of point to it. So minimum y value, and the maximum y value is 2. So that's it. You can just feed that into the interval notation, minimum, comma, maximum. The intercepts, they have those all marked in red here and listed here as ordered pairs. All right, it says draw the horizontal line y equals -1 on the graph, and notice how many times it crosses or intersects the graph. It intersects it 4 times. That's all there was to that question. Let's see. We can see, they're asking, yeah, it looks like they're asking for the minimum. Let's go back to the question. Sorry about doing this. Might look, okay. For what values does f of x equal -2? So now, what values of x? So they're saying, look here, what were the x values, not the y values. I know the y value is -2, but what were the x values? And they were 3 pi over 4 and 7 pi over 4 is what we were going to find out. Again, sorry about scrolling through the video. All right. So gave us those values. So hopefully you can see that what's going on here is they can ask us questions about the graph, whether we have the graph or not. And these are very powerful questions because they force students to maybe draw the graph, but even if they don't draw the graph, they still have to, or even if they do draw the graph, they still have to do more steps possibly in the process. So here they're asking, when is the function greater than 0? So it's an interesting question. What they're asking is, what are the x values that make the function greater than 0, make the y value greater than 0? And so I'm shading the number line here. There are 2 intervals from 0 to pi over 2, this interval, and from pi to 3 pi over 2, this interval. And that's it. Everywhere else, the graph is either equal to 0 or it's the y value is below the x-axis, so it's negative. So they give us that, and all right, and they start another example. All right, so we have this function, find the domain. I'll go ahead and do some of these right here. Just, I'm ignoring the numerator. Doesn't have anything to do with this problem when we're looking for the domain. The denominator is not equal to 0. I get x is not equal to -4. Depending on how they ask us to express that, might do something. Okay, is this point on the graph 1, 3/4? So I know it's not because if I plug in 1, I'm going to get 4 over 5. In other words, when 1 is the input value, the x's change to 1s, but that tells us it's also not in the graph. If x equals 2, okay, we'll just go through the work here. So here's the function kind of sitting off to the side. We already found the domain. They asked us to go ahead and put in, or the way they answered yes or no to that one question is, what if I put in 1? What would I get? So in other words, I've made the world's smallest table 1. I get 4 over 5 rather. If I had gotten 1, 3, 4, then the answer would have been yes, that was a point in this graph. But no, this is the point on the graph. And remember, because it's a function, there's only one point at 1. You can't have this situation where you put in a 1, you get 4 over 5, and you put in a 1, you get a different number. So we know that. If x equals 2, they just did f of 2, right? Substitute it in. If x equals 4. Now they're not saying x equals 4. They're saying if y equals 4, what's the value of x? Okay, so that would be like having this as your starting table. You're picking your y value, and you have to calculate your x value. Well, here's the problem with doing that. I mean, we do it all the time in algebra, but the problem with it is we try to avoid that because this was a machine made to find y. In other words, if I wrote it as y equals x plus 3 over x plus 4, remember y is the is the dependent variable. X is the independent variable. X is the one where I can just pick a value for x, and y is what I calculate. Trying to put 4 in for y and then calculating this, it works, but it's a lot more work. So when you have a choice, you're supposed to pick x, but when they pick y, you've got to solve for x. All right, so we find out it is negative 13 over 3. In other words, if I did put in negative 13 over 3, I would get 4. Finding the intercepts. Well, to find the intercepts, 1 is you let x equal 0, and that will calculate the y-intercept. But here they're letting y equal 0. So once again, they're giving us y, the y value. We have to solve for x. So they gave us the y value of 0. The x value was negative 3. So that would be the x-intercept, the 1 x-intercept. And to find the y-intercepts, we try to solve this. So turns out this has, let's see. Oh, we go ahead and solve this and get x equals 0. So that's the only intercept. All right. So so what happened here? I'm trying to see what. Oh, yeah. If setting this equal to 0 would be like setting the numerator equal to 0. But I mean, I already went through it. Okay. Thought there was something deeper going on here, but there wasn't. All right. All right. I think we've done most of the questions. Let's roll back. What were the questions that they asked us to do? Oh, find the x-intercepts of the graph. If y equals 4 is what this is saying, what's the value of x? It's a more challenging question than if x equals 2, what's the value of y? All right, so all of those are questions about the graph. They weren't the graph itself. We'll talk about graphing in a much later chapter. I think it's chapter 5. We talk about graphing things like this. But we're still in early sections of chapter 3, and they're asking us a lot of questions about the graph, which is an important, I guess, foreshadowing for what we're going to be doing later. So actually, you might have been able to tell, some of these questions are just kind of a little awkward now. We have much more streamlined questions we can ask, such as what is the asymptote, what is the domain, what is the range. I mean, very streamlined questions about this type of thing moving forward. And they're just asking what they can in an early section about this topic. Still important, and it's going to be very important so we can understand things moving forward. In any case, that is my lecture on, what was it, section 3.2.